2, will that be the value always for two-sided Z test? Or there will be a role of mu naught in it?
You were saying 2 fz bracket in bracket minus c upon something, correct?
2, no, no, C value is equal to minus sigma by root n.
It depends upon the question.
No, it's a two-sided.
That I got it, but it depends upon the question, na? Ki what is your question? So with that, only I will get the equation of C. I can't tell you like it's not the general thing, but it depends
But
upon the
we
question.
approach everything the similar way. That is why I thought this can be deduced as a general expression.
Uh, uh, um, okay, so like if you have any question or something, or in the mock, is there any question?
Not in the two-sided test. I cannot deduce in the fifth question. Is it a left-sided test or a two-sided test?
Okay, so we will go one by one with each of the question. Okay, and then also if you have any doubts, we will just solve it. Okay.
Okay, thank you.
Okay. Good evening, everyone.
Good evening, ma'am.
Good evening. Okay. How's the preparation going on? All good?
Yes, ma'am.
Yes, ma'am. There
All
is a
good?
lot to revise also.
There is lot to revise. Okay. Like from 9 to 12 or from the whole thing?
9 to 12 is sorted, ma'am. 1 to 8 is like I'm feeling lazy.
Okay. So you have to repeat it once again, right? I can understand. It's fine. You have to do it, right?
Yes, ma'am.
Okay. So everyone has submitted their mock paper
Yes,
assignment.
Yes, ma'am.
Yes, ma'am.
Yeah. Was it easy?
Ma'am, some of them questions were some tough like or some confusing bit.
Okay, that's not an issue. We'll just do one by one all the questions. Okay. So shall we start now?
Yes, ma'am.
Okay. Okay, so the first question is consider 100 samples x1 to x100, which is an IID normal mu comma 1. Let the null and alternative hypothesis be mu equals to 0 and mu greater than 0. Suppose the test statistic is x bar. Consider a test that rejects h naught if t is greater than c. Okay. Now, what is the probability of type 1 error? So, what is probability of type 1 error?
Now reject H naught when the H naught is true.
Yeah, correct. So, we need to find out what?
Alpha.
We need to find out alpha. So have you guys done this question?
yes, ma'am.
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay, let's do it. Sorry,
Here we'll do a right tail test.
we will do a right tail test. Correct. Okay. So let's go through the question once again. So we have a question in which I have x1, x2 till 100, which is an IID sample following a normal distribution with mu comma 1. Okay, we have an null hypothesis which is mu equals to 0 and alternative as mu is greater than 0, right? Then we need to find out, okay, then we have the test statistics, which is x bar. And what is my test? Test is I would be rejecting h naught if, what is the condition?
T is greater than C.
T is greater than C. This is my condition. Okay, now the first is I need to find out the probability of type 1 error. So that means I have to find out alpha. Yes or no? This is my probability of type 1 error. Correct?
Yes, ma'am.
Okay, now. So this is probability of rejecting h naught given mu equals to 0. That means my h naught is true. So the next step is
T greater than C given mu equals 0.
t greater than c given mu naught equals to
X
0.
bar is greater than C.
Oh yeah, so we can say that x bar is greater than c. Correct. Okay, then the next step.
So you normalize this.
Or minus change it into Z
Z,
form.
Z greater than C minus mu by the standard
X bar
deviation.
minus mu by sigma by under root n.
Okay, so what is the sigma here?
Sigma is
1.
1 here.
And it is 100.
And
Root
the sample
will
is
be 10.
100.
Okay,
Simply, ma'am, 1 by 10.
it will be 1 by 10. Okay. Now, so this can be written as next.
1 minus fz.
1 minus fz of 10c.
Just a second. So this will be 1 minus fz of c minus, okay, so 0 is not there, so it will be c into 10, correct? So this will be 10c, right? So this is my alpha. Is the question clear?
Yes, ma'am.
So yeah, answer is there. So it is 1 minus fz 10c. Okay. Now, what is type 2 error?
1 minus beta.
1.
Except H0 while H8 alternative is true.
Yeah. So basically, we need to find out probability of type 2 error. And type 2 error is R. What is our type 2 error? Beta.
Except
Beta.
H0 when the H0 is false.
That is probability of accepting H0 given my alternative is E, right? Okay. Now, next step. What is the condition for accepting the H0?
T is less than c.
Less than C, and here mu will be 1.
Given HA or mu equal to 1.
Mu equals to 1. Okay. Now, same step. Beta is equals to probability of Z less than C.
Minus 1.
Madam, sorry to interrupt. I followed with the left hand side 1 minus beta as a for power. Then last finally I cancel out. It's okay, right?
Sorry, once again, what?
So LHS side, 1 minus beta I kept and I followed the steps.
1 minus
finally
beta
1 I
is
get.
actually the power,
Yeah,
right?
Yeah, so that finally that both side 1 I cancelled.
Oh, okay, fine.
Is it okay?
Yeah, but
That
it's
time we
fine.
need to take T greater than C if we are taking as power as
Yeah.
our
Power.
Yes,
condition.
greater than beta.
Okay. Okay, then. So this will be C minus 1 divided by 1 by 10, correct? So simply this will be FZ
C minus 1 by 10 10C minus 10.
enough. So this will be beta.
Yes, ma'am.
Is this fine?
Yes,
Is the
ma'am.
question clear? So these two questions are clear to everyone? No doubts? Yes or no? Can I get a thumbs up? Okay, fine. Okay, let's proceed to the next question. Let X be uniformly distributed over the interval minus A to A, where A is greater than 0. For what value of A, probability of X less than 1 by 2 is 0.07. Okay. Okay, so what we have been given that it's following a normal uniform distribution. Okay, so X is following a uniform distribution with intervals minus A to A, where A is greater than 0, and we have been given that probability of X less than 1 by 2 is equal to 0.7, right? So if you remember, if my X is following a uniform distribution, okay, in general, A comma B, then probability of X less than X can be written as
1 upon B minus A.
1 by B minus A PDF.
just
X minus A by B minus A.
Minus A by B minus A.
correct. This is
Yes.
actually
CDF.
what my
CDF.
CDF, right? So if you just
Yes.
if you just compare this equation with this equation, basically this is my CDF. So in place of 1 by 2, in place of X, I have 1 by 2, right? So I can write this as, so this value is what? 1 by 2 minus A, that is the first value, the first limit, which
So
is minus
positive
A.
A.
So this will be positive A. Now divided by B, B which is A minus minus plus A, correct?
Yes, ma'am.
So this will be what? 1 by 2 plus A equals to 0.7 into 2a, right? Yes or no? Is this step
Yes.
clear?
Yes, ma'am.
Okay. So if you just solve all of these equations, the value of a should be equal to 1.25. Okay. I'm not solving the whole question, but yeah. Is it clear, this question? To everyone? Huh?
Ma'am, in nominator, ma'am, 1/2 plus a how?
Once again, what?
Ma'am, 1/2 plus a upon a plus a equal to 0.7. Ma'am, here in numerator, 1/2 plus a.
1/2 plus a.
How
1/2
can be
plus a.
this?
How can
Yes,
we?
ma'am. How can be this?
How can we solve this?
Yes, ma'am. How can we solve it?
Okay. So this will be this till here. Is it fine? This is 2a. So 2a will be multiplied by here by 0.7. Is this step clear?
Yes, ma'am.
This step is clear? Yes or no?
Yes, ma'am. This step is clear, but
हाँ.
ma'am, I confuse 1/2 plus a. How can this मतलब ये कैसे ये हुआ 1/2 plus a?
आप न्यूमरेटर की बात कर रहे हैं क्या? ये आया कैसे?
Yes, ma'am.
देखो हमारा सीरीएफ क्या है? x माइनस ए
Yes, ma'am. X minus
है ना? तो x
yes,
की
yes,
जगह हाँ तो x की जगह यहाँ पे क्या है? 1/2.
yes, ma'am.
ठीक है, तो x की जगह मैंने 1/2 लिखा और यहाँ पे माइनस ऑफ a है. माइनस मैंने यहाँ रखा. a मेरा क्या है? जो मेरा फर्स्ट लिमिट है यूनिफॉर्म का, वो क्या है? मेरा a है. तो इस क्वेश्चन में देखेंगे हमारा फर्स्ट लिमिट क्या है? -a है कि नहीं?
Yes,
यस
ma'am.
और नो? ठीक है, तो मैंने यहाँ पे -a लिखा. तो मैं इसको सॉल्व करूंगी, क्या आएगा? 1/2 + a.
Yes,
समझ आया?
yes, ma'am.
ठीक है, अब क्लियर है?
Yes, ma'am. Clear है, मैम. ये मैम ये PDF के लिए है.
हाँ.
Sorry, ये CDF के लिए है.
PDF
Then
है.
PDF के लिए हो जाएगा 1/b minus a.
हाँ.
Accordingly.
ठीक है.
मैम यहाँ पे मैम इसको डिफरेंशिएट करके लाया जाता है ना, x minus a upon b minus a.
नहीं नहीं, ये सीरीएफ है ना, ये इंटीग्रेट करके लेके आप.
Oh, sorry, integrate. Okay, okay, ma'am.
ये क्वेश्चन क्लियर है?
Ma'am, how do I know it's CDF or it's PDF?
Okay, so can you tell me? Okay, I'm writing something. So probability of x equals to x. What is this? PMF or this is
it can be both. Nah.
how can
Can be PMF.
it can be PMF, right? It is PMF.
Oh, okay.
We are finding out the probability.
Yeah,
Now,
for CDF it's less than or equal to.
less than equal to. So this will be
yes,
CDF.
yes.
Okay?
Yeah. Now I'm clear.
Question second is clear to everyone. Can I proceed further?
Yes, ma'am.
Okay, fine.
Yes, ma'am.
Now, 1 point. Then, fourth question. Let the random variable x and y each have range 1, 2. The following formula gives the joint PMF of this. Okay. Where k is an unknown value. Find probability of x going from 1 to 2 and y going from 1 to 2. Okay. Have you guys solved this question?
Yes, ma'am.
Yes, ma'am, I did.
Okay. So how you did? So they are saying that
Okay,
x
ma'am.
is having
This is
range.
joint PMF, so I made a chart there, table. So
For I equals 1 to 2, so we have x equals 1, y equals to 1, 1, 2, 2, 1 and 2, 2. So we'll get the
So first of
component.
all, we will make the table, right? So it will be 1/2, since this is the value
Yes.
of x and this is the value of y, 1, 2. Okay. So what is this value?
yes. This will be 2 by k.
Okay,
1 plus 1 by k, so it is 2 by k.
good.
And
2 by
next one
k.
will be 2 plus 1 by k, that is 3 by k.
Three
Again,
by
in
k.
the, no,
2 by k.
yes,
3 by
this is
K,
4
3
by
by
k.
k.
4 by K.
4 by
And
k.
last one is
Adding
by
all
k.
them will give 1.
yes,
Adding
From
all
there
of
we can
them, we
get
will
the
get
answer of
1.
k.
1.
Okay, so
Yes.
if we add everything, which is 2 by k plus 3 by k plus 3 by k plus 4 by k, it will be equal to 1. So by solving this, my
Yes.
value of k is coming out to be
12.
12.
It is 12. So we have the value of 12. What we need to find out? Probability of x 1 to 2 So probability that my x is going from 1 to 2, comma, y is going from 1 to 2, correct? This is the thing?
Yes. No, no, no,
No,
no.
I think
There
y,
is not
one is not inclusive
not
in
equal.
y.
Actually.
Okay.
Yes, it
So
is
this will be,
excluding. Yes.
so we need to find out what? How are we going to find out? So
1,
this will be
2 plus
probability
2, 2.
1, 2,
that,
2, 2.
so this will be 1, 2 plus 2, 2. Okay. What is this value? 1, 2?
3 by 12.
3 by k.
3 by 12. And this value
3
is
by 12
2,
is
2?
4 by 12.
4
4
by
by
12.
12.
So this is coming out to be 7 by 12?
So 7.
7 by 12. Yes, ma'am. You're right.
Yes.
Yeah. Is this the answer? 7 by 12.
Yes.
Is the question clear to everyone? The fourth question?
Yes, ma'am.
Okay.
Ma'am, can you just explain the last step?
Can you? What?
Ma'am, the last step, that this one. Yes, ma'am.
Yes.
How this probability is equals to 1, comma y is equals to 2. How this
See,
came?
what they
I
are
mean,
saying,
from
they are
this.
asking that what is the probability that my x, see, my value of x is basically what? Two values are there, right? 1, 2. It's in that range, right? And y is
Yes,
also going from 1 to 2. Now we need to find out that my x is taking values from 1 and 2, and y is going from greater than 1 but less than equal to 2. Correct? So in general, what are the values that I am having? I am having 1 and 2 and 1 and 2 only, right? So for x equals to
Yes, ma'am.
1, my y will be equal to 2 only, because the value of y is going from range greater than 1, not equal to 1, and less than equal to 2. So basically y will be equal to 2 only, and x will take two values, which is 1 and 2. Okay?
Correct.
Correct?
Okay.
Yeah.
Yes, ma'am.
So that's why we have x equals to 1, comma y equals to 2, plus probability of x equals to 2, comma y equals to 2. Okay, these are the two conditions.
Okay, ma'am. Yes,
Yes, ma'am.
No,
Because it is discrete distribution, no?
that's
Right.
okay, ma'am. Thank you.
Okay, so can we proceed to the next question? Fifth question.
Yes, ma'am.
Yes, ma'am.
Okay, fine. Now, the standard method of screening for a disease fails to detect the presence of the disease in 15% of the patients. To determine if the new method of screening is superior, suppose that 75 people with the disease are chosen at random and screened using the new method. The new method failed to detect the presence of the disease in 6 of the patients. Okay. Identify the null and alternative hypothesis. What is the null hypothesis here?
Equals 1.15.
H naught is equal to P equal to 0.15.
P equals to, okay, and alternative?
P less than 0.1.
Less than, because it fails, right?
Mm-hmm.
Ma'am, am I right? Because it fails, that's why we have to take it's less than.
Yes, I did the same.
The standard method of screening for a disease fails to detect the presence of the disease in 15% of the group. The method is superior. Yeah, correct. So P will be less than 0.15. So null and alternative hypothesis will be H naught equals to P equals to 15. Okay, and alternative would be that P is less than 0.15. Question 5th is clear. The null and alternative hypothesis. So we have the null hypothesis as H naught equals to P equals to 0.15, and alternative as P is less than 0.15. Then next question. Find the P value of the test. Okay, what do you mean by the P value? What is P value?
P value is the value of alpha at a given value of C.
Lower
Basically, the lowest significance value.
We'll just put the sample.
The C value will be, according to the C value, we have to check the value of alpha. Okay. Okay. So, so here the question.
A small query. Lower significance value at which we reject, right? Reject H naught.
Okay. Yeah. So in total, how many samples are there? We have 75 samples on the new method failed to detect the presence of the disease in 6 of the patients. So this is the, okay. So this is like a, let's suppose the binomial case. right? So let's suppose my t would be what? x1 plus x2
Correct. Till
till 75, which is following a binomial. There are 75 samples, and p is the probability of success. That means probability in the sense of detecting.
Yes,
right?
ma'am. Yes,
Yeah.
ma'am.
Okay. Now, so this is my t here. So so
Mean
this
would
t
be
will be following normal
NPN.
distribution with 75p, 75p into 1 minus p. Correct?
Yes, ma'am.
Yes,
Right?
ma'am.
Now, if I have to find out the x bar, this will be following normal distribution with parameters.
Could you repeat this step and this previous step, like how it is for, like how it is following normal distribution with 75p
Acha,
and
dekho. T is like the sum of all these values, right? Yes. Let's suppose this is my x. This is x, which is following a binomial 75 comma p. Now, if x is following a binomial, what is the expectation? Expectation of a binomial with okay, I'm asking if it's
75p.
following. It will be 75p, right? And what is the variance?
75
75 p into p 1 minus p.
Right?
into
So,
1 minus p, yes.
So this will be following normal. This is my expectation and this is my variance. Now, is there any doubt?
Can't we do it like directly?
When
Like
n
instead
is
of converting it to an normal, can we do it directly by binomial?
Binomial.
Yes. Okay. First you calculate and then next step, then I will ask my doubt.
Yeah, okay. So now x bar I have to calculate. So this will be following normal distribution with what parameters? For x bar.
75p
For x
and
bar,
75p only.
x it will be equal to mu, right? So it should be p, right?
It should be p and p of 1 minus p.
It will be p 1 minus p divided by 75.
Because x.
Ma'am, I'm confused. Once could you repeat this step?
Expectation of x bar would be what? Expectation of x1 till x75 divided by 75, right? Now, for each of the values of expectation of x1 till expectation of x75, right? Divided by 75. Now, for
It
each
will
of
be
the
like 75 times expect p of
so
x
this will be
n by
75p
75.
divided by 75. So this will be p only. Okay.
This is the expectation of sample mean, and the variance, the normal follow, that is variance of sample mean.
Correct.
It is we learned it is in week 3 or week 4. There is sample variance of sample mean, expectation of sample mean.
So if you remember, my the sample mean will be following what? Normal distribution with mu comma sigma square by n, right? So this is the same thing. So mu, it will be for each of the x's, my mu is what? P, and sigma square will be what? So see, basically
Sigma will
what
be
it
like
is saying,
NPQ,
my
NP1
xi
minus
is
P.
following a Bernoulli with parameter p, right? Okay, so x1 is my first sample, x2 is the second sample, as in I have 75 samples, right? So for each of these samples, I am having a probability of success, which is p, the parameter p, right? So my x bar would be following a normal with mu, which is p, and sigma square is what? P 1 minus p divided by 75. Fine?
Yes, ma'am.
Madam, above statement P, P is following again. That one, the two steps are quite confusing, madam. Could you please explain this one? So, above one. So, there is a sample mean X you calculate.
Let's take it from the start.
P and
Let's
X bar.
Okay, let's take it from the start. Okay, so basically I am having, let's suppose I am having xi samples. Okay, so for the first sample, I will have two values, right? I will have 1 and I will have 0. So one is basically if it detects and if it do not detects the patients. Okay. So so basically this is what? Bernoulli with parameter P. Yes or no?
Yes.
Yeah. Correct?
Yes, ma'am.
Yeah.
So I can just
Yes.
generalize into xi also. So it will be Bernoulli with P as a parameter for all the xi samples. So I is basically going from 1 to 75. Yes or no?
Yes.
Yeah. Okay. Now,
Yeah.
and what now? If my, let's suppose my x is equal to the sum of all these samples. So sum of all these sample will be following what distribution?
Binomial.
This will be binomial with parameters
75p.
75 comma p, right? Okay.
Yes.
Now if x is following binomial 75 comma p, okay. So now test is basically what the sample mean. Yes or
Yeah.
no?
Yes.
Okay.
Yes.
Now the sample mean would be following a normal distribution with what expectation? So let's find out the expectation. So expectation of sample mean is what? Expectation of x1 till x75 divided by 75.
Yeah.
Correct? So
Yes,
this will be
correct.
equal to what? P.
P
So this is
75.
my sample expectation. Okay. Then we will find out the variance. So
Ma'am,
variance of x bar.
ma'am, just a doubt. Why this T is following a normal distribution? Like
We are
initially,
approximating it to a normal distribution with parameters, the expectation and the variance.
so is it like we are assuming it to like?
Yeah, this will be following a normal distribution.
Correct. Okay.
Yeah. Okay.
Okay.
So this will be divided by the 75, right? So
Yeah.
if we calculate this value, we will be getting p into 1 minus p divided by 75.
Yes.
Yes.
Yes. Yes.
Okay. So we have got the expectation and we have got the variance as well. Correct?
Yeah.
Yeah. So we have the t, which is x bar, which is following a normal distribution with p comma. This is the step.
Excuse me, ma'am.
Ma'am,
if we are taking binomial distribution and the variance of binomial distribution is np into 1 minus p, so it should be 75p into 1 minus p, na?
No, just calculate this value. So this will be what? 1 by 75 square into variance of x1 till variance of x75, correct? And each of the variances is equal to what? The sum of all these. It will be 75 into p into 1 minus p divided by 75 square.
Yes.
So 75 will be cancelled out. So I will be left out by p into 1 minus p divided by 75. Yes?
Yes, okay. Thank you.
Yeah. Okay. Okay. So my t is following, which is x bar, which is following a normal distribution with parameter p comma p into 1 minus p divided by 75. Yes?
Yes, madam.
Yeah. Okay. Now the next step is
each element is following binomial or Bernoulli distribution.
Each element is following a Bernoulli, and the sum of all the elements will be equal to the binomial.
Yeah. Okay.
Following a binomial distribution. Okay. Okay. Now what is the p value, which is alpha, which is equal to probability of rejecting H naught. Given my H naught is true, correct? Now, what is the condition for rejecting H naught?
X bar is greater than
Less than
C.
Less than C. Given my H naught is true, which is, what is my H naught?
0.15.
0.15. Okay. Now, what is my C here? According to the question.
6 by 75.
6 by 75. Is this thing clear? How is my C 6 by 75?
Ma'am, how you calculated C?
So in the question, they have been given that the new method failed to detect the presence of the disease in the 6 of the patients. So from the 75 people, 6 of the patients failed to detect the presence of the disease. So that is my C. So C is basically what? We are just calculating, like we are taking the value from the samples. So this is my sample. From the sample, I am taking the value which is 6 by 75.
Isn't like
the proportion.
probability?
What probability?
Like calculating probability, like method.
Like we are calculating the proportion. Like what is the value of C? So like what is p value? P value is basically from the samples we have to calculate the value of alpha, right? So what is by C here? C is the proportion of
new method failed detect presence.
Correct. Okay.
From all over.
So this is my C here. Now this will be equal to probability of x bar less than 6 by 75. What is this answer? 6 by 75 will be 0.08. So this is 0.08 given p equals to 0.15. Now I will convert this into a standard normal variate. Yes or no?
Yes.
Yes, ma'am.
So this will be z less than 0.08 minus
0.15.
Yeah, 0.15 divided by
0.15 into
square root of
0.85.
1 minus 0.15 divided by 75. Now you got it. This is basically what the expectation, and this is the variance from where we calculated this value, right? This thing. This is the expectation, and this is the variance. That's why we are just approximating it with two normal distributions so that we can standardize this expression. Fine? Yes or no?
Actually, here we placed the standard deviation, sample standard deviation, not variance. We used under root, right?
Standard deviation, yeah. Okay, so if you solve this value, you will be getting what? This will be fz 0.08 minus, so something, this will be equal to minus 1.69. Okay, now what is this value?
0.05. So actually 1.699 is coming, but the matching one not
0.045.
0.045. So this value is 0.045. Okay, got the question? Is this the answer? 0.03, so 0.04. Okay, fine. Yeah.
Ma'am,
is the question clear?
Ma'am, sorry, ma'am. What is the value of 1.15 you are taking? The 0.08 minus of what? The next step.
This is P. Okay, I'll just. Okay.
Okay, fine.
Yeah.
Ma'am.
Yes.
In the under root, we are taking the standard deviation, but don't we take the number of trials?
No, this. Okay, so what is this? This will be C minus the mu naught divided by the sigma by under root n, right? So what is my sigma? Sigma is the under root of sigma square, right? So I've just written it as C minus mu naught under root of sigma square by n. Is it fine?
Oh, okay.
Okay. Is the question clear? Question number 6. Is question number 6 clear? Yes or no?
Ma'am, yes. 1 second, ma'am.
Yes, ma'am.
Yeah.
Sorry, ma'am. Can you go to that problem once, ma'am? So, ma'am, generally for this sigma by root n, we will do that for the sample mean only, right, ma'am? So I know you said like proportion is there. Can you please repeat that one more time, ma'am? So that because see this sigma by root n we will generally get for sample mean, but here there is no mention of any sample mean or something, but still you are using sigma by root n. That part I'm not, because there is one more sum with the same binomial where you put n into t into 1 minus p. So that is getting confused a lot, ma'am. Which one to use?
N into what?
Square root of n into p P into 1 minus P in some other activity, the similar things, use that kind of a formula for the denominator. So I'm wondering, like, why we are using this formula, or like on what basis we need to use this formula?
That is for binomial and this is for Bernoulli.
So this is the case of binomial, right? So first of all, I need you to find out the x bar is following, which like I need to approximate it to a normal distribution with some expectation and with some variance. Okay. So we that my x is following a binomial 75 comma p, right?
Yes.
Now I need to find out the sample mean of this, right? So if I need to approximate this into a normal distribution, I need to find out its expectation and variance.
Yes, ma'am.
Yeah. Okay. So if I need, so what will be my expectation of x bar? It will be p only.
Yes.
If I calculate this, okay, then variance will be p into 1 minus p divided by 75. This is from the calculation. I'm not saying anything. Okay. Like just if you don't know how to like put the values, just calculate it. Expectation of x bar and variance of x bar. Okay. So that is the value of expectation and variance. Now you have x bar is following normal p comma. So like in normal general process, my x bar was following a normal distribution with what? Mu comma sigma square by n, right? Yes. Then we did the standardized, we converted this into standardized by c minus mu divided by sigma by under root n, correct?
Yes.
This is the general thing. Okay. So in place of sigma square by n, I have p into 1 minus p divided by 75.
Which you are taking root. Okay.
So this will be just, this is under root of sigma square by n, which is 0.15 into 1 minus 0.15 divided by 75. That's it. Okay.
Okay. Ma'am, for all the sample, the IID sample, you are finding variance and V of x and then just using that value. Okay. Okay. Thank you.
Okay.
Ma'am, over here I'm having a small doubt. The main x bar is following a Bernoulli P, right? From there we are deriving.
Main my xi is following by Bernoulli, and my x is and my x, which is the sum of all the sample, will be following binomial.
Yes, ma'am.
Yeah. Okay. And will you accept or reject the null hypothesis at a significance level of 5%? What you would be doing? Accepting or rejecting the null hypothesis. What is my p value here? P is coming out to be 0.045, right? And my alpha. So what is p value, which is the lowest significance value? And my alpha they are saying is 0.05. And my p value is coming out to be 0.045, right? It is less than alpha. So will I reject or accept the null hypothesis?
We'll reject, ma'am, because it's too extreme.
We will be rejecting the null hypothesis. Fine?
Yes, ma'am.
Is this question clear to everyone? Is the whole question clear to everyone?
Madam, yes, we calculated the p value, yes, right? Again, we need to calculate alpha value also.
No, alpha value is already given in the question, right? The significance level of 5%.
Okay.
Yeah.
So we need to compare with the
alpha.
The p needs to compare with the alpha only. Okay. But normally we'll do mean value, right?
Normally we do what?
Mean value. We'll compare with the mean value, right?
Normally we compare it with the like we compare it with this value, right? My condition was t if my t is greater than c or t is less than c. So we first we calculated the value of c and then we compare it with the t, like that. Okay. Okay.
No. So if for example, if you are not calculated p, then we'll compare with that is sample mean, right? So we compare sample mean, right?
We
so
compare
here,
it.
That area is just quite confusing, you know, actually. So normally, without calculating p value, we will compare with that mean value and we will decide reject or accept, right? But here we are comparing with
the alpha value.
Yeah.
Okay. So
ma'am, here since it's a left side test, so if alpha is greater than 0.45, sorry 0.045, we should accept, right? As per the graph. My doubt is that. because lowest significance level at which we accept in a left side test I'm talking. Do you get my point, ma'am?
Less than C.
Ma'am, it would be better if we do the latter part. Like first we would find the C using the significance level and then directly test it with the mean. That mean this I'll find using sigma to compare the P is like very confusing.
What?
It would be better if we like do by the normal method, like finding C and then comparing it with the.
No, but you don't have the value of C, right? That means you don't
we
have
have
the
right, ma'am. 6/75.
You can find it.
Yeah,
using
that
the
is C. So we have the
sorry,
value of C. Let's suppose
We have the value of mean and all right, ma'am. We can directly find the value of C at 0.05 alpha levels. So we will get a value, then we can compare it with the C, right? Which
yes,
is
exactly.
Yeah, that could be a method, but here in exam we don't have that much of time because 2 questions are given. So they wanted us to use this method which ma'am used in this question.
See, we can have a question in which you don't have the value of alpha as well, 0.05. Okay. In the next question, if you see here, the question in the second part only they have asked, will you accept or reject the null hypothesis at a significance level of 5%, right? But in this question, they have not mentioned you any significance level in the first part. Have they mentioned it? No, right? So without, like, if they are not even mentioning what significance value you have to use, how can you calculate the value of C?
Yes, ma'am. That would be a
Yeah.
problem. Then.
So, ma'am, we are comparing it with p-value.
So just remember one thing. If we are comparing like alpha and p value, right? If my p value is coming less than alpha, we would be rejecting H0. Okay. And if my p is coming greater than alpha, we would be accepting H0. Right? So just take it as a simple thing. So this is
like
what is my p value? It will be equal to my the sample, right? The sample mean.
Yes, ma'am.
That is the t, right? So if, and let's suppose this will be my alpha region, correct? So when my critical value is this thing, my alpha region would be this part, my alpha dash something. So this would be my p value here. So if my p value is coming less than alpha, I would be rejecting it. Still, I would be rejecting the H0. But if my p value is coming greater than alpha, like suppose like alpha is here, my p value is coming out to be somewhat here. Okay, then I would be accepting the H0 because it is not in the range of alpha.
Ma'am, actually this is a left tail test, right? So
yeah,
in case of left tail test, so if this value is going to be lesser than alpha, we'll accept, right?
Ma'am, can I explain intuitively? I mean, whatever I know. Actually, I had the same doubt. So basically, what happened when we calculate p-value, we first accept that alternative hypothesis is true. Then, what is the probability of the sample? So, if the probability of sample is very low, that means it is very rare. Still, this is happening. So that's why we reject the null hypothesis. And if suppose the probability is maybe 60 or 70%, that means there is a lots of possibility that can happen. So that's why we accept it.
Ma'am, when you were giving the solution,
see, if it's a right-tailed or a left-tailed test, right? So,
ma'am, when you were giving the solution, you was right, but right now, while writing this concept, you got confused, I guess.
See, the main thing is if we go by the theory, right? So P is the lowest significance value. So if my P is less than the significance value, right? So I would be rejecting H0. Okay. And if it's whether a left-tailed or a right-tailed test,
Madam, normally, so that rejection region will condition for the left side. X bar less than C. That is the condition, right? So how we can correlate with this one, but this P and alpha.
Just a second. So, like you are saying that if my p value is greater than alpha, then only we would be rejecting H naught. Like somebody was saying this thing, right?
In case of left tail test.
Case of left tail test.
I'm not really
like ma'am, we are saying X bar should be less. If X bar should be less than, we'll reject. But here our X bar is like 0.45 something, 0.04, and alpha is 0.05. Then we should accept now, because alpha is greater than, and we need for lesser than.
Ma'am, the graph would form at the left side of the graph. Yeah, you take
I checked
alpha.
on the internet.
You fix alpha over there. Alpha is fixed over there. So the right side of the alpha will accept, and the left side of the alpha will reject. In general, in a left tail test. So 0.05 is greater than 0.045. That's why our argument is like we have to accept. Am I right, everyone?
Yeah, I was also thinking the same.
No, see, my question for the X bar less than C as per the left tail, then here P and alpha is coming. That's quite confusing. So how to correlate? So C we need to correlate with which P or alpha. Madam, could you please write, madam, X bar less than C? That is the condition, right? Rejection region for the left tail.
Yes, yes.
Yeah. So now we are calculating the different times P and alpha is there. So how we can correlate this one?
Sir,
So
that is normal method, sir.
Value, less than the C, this we can be very clear. So for this, okay, C less than P is less than C.
According to the internet, he will always reject the null hypothesis if the p value is less than alpha. Whether it be right tail, left tail, or two tail test.
Yeah, because the main thing is, see, my p value is the lowest value, right? When we would be rejecting the H naught, okay, the lowest significance value. So you just have to remember this thing, whether like.
Okay, ma'am.
Yeah, so like, just remember this thing only. If my p value is coming out to be less than alpha, okay, the lowest significance value, I would be rejecting H naught. Okay, and if my p is coming greater than alpha, because if you are taking left-tailed or right-tailed, the same thing will be applying to the left-tailed as well, and the right-tailed as well. So if you see, like the p value is 0.04 and my c was 0.08 and my alpha is 0.05, then also my p value will be coming out to be here, like 0.04 right here, right, which is less than my alpha, correct?
Yes, ma'am.
Yeah. So then also I would be rejecting my H naught. Correct or not? This is my 0.05. Let's suppose this alpha is 0.05 and my p value is coming out to be 0.04. Then also I would be rejecting my H naught. Yes or no?
Yes, ma'am.
Yeah. So if it is right tail or left tail, the same thing will apply to both of the cases. My p is less than, if my p is coming out to be less than alpha, that means if my p value is less than my significance value, then I would be rejecting my H naught. And if my p is coming greater than alpha, then I would be accepting H naught. Whether it's a left tail test or whether it's a right tail test. Okay. The same thing will apply here as well. Same.
Okay, ma'am.
Yeah.
Okay, ma'am.
Like if we have p value, we always reject.
What?
What? Sorry, pardon.
Once again?
Like if you have p value, left tail or right tail, and some smaller value, some c bar, then we will always reject either left or right.
Ma'am, I'm a bit confused when it comes to right tail now, because if p-value is going to be greater than alpha, then it will fall on the region like to reject, right? As per this definition. Say, for example, alpha value is 0.7 and p-value is going to be 0.8. And if it is right-tailed, p-value will be greater than alpha. And that region is what typically we reject in case of right-tailed test, right?
Yeah, can you once again what?
Like alpha is 0.05. Like let's consider the right-hand side now, and p-value is going to be 0.06 or something. P-value is going to be greater than alpha. In right-tailed test, it falls on the region of rejection, right?
But my alpha is my rejection region. If let's suppose this is my p coming out, but my rejection region is this, right?
Yeah, but we argue here p is
so
greater
my
than
p,
alpha.
this p value is basically coming
Greater than alpha in the sense it's right hand side, right?
Right hand side. So alpha, like this will be my p value, right? Not the alpha.
If p is greater than alpha, then
this is my alpha. If you're saying that my p is greater than alpha, that means
Madam,
somewhat it is
madam,
coming
that
out.
line, see, alpha is a rejection area, right? Not the point, right? It is C only, right?
When if p is greater than alpha, then p should be in the right of alpha, right? And not in the left of alpha. That's
See,
it falls into the rejection.
madam, see, I confused about the notations. C only will use, right? C and P is the C is and P is lower than the C. So alpha, why we are writing here? So alpha is a rejection area, right?
Even P is an area, not a point.
P is the value at which we get. P is the value of alpha at a given C, right? We are doing it in another method, sir. I hope I was clear.
I'm confused with the notations only. C and P I am very clear, but alpha, why we are mentioning it, I'm not able to understand.
P is also an alpha, sir. P value is also an alpha.
No, alpha is a significant value, right?
Yeah, even P is also a significance value.
No, P is the lower than the significant. Okay, lower than the C. Yeah, P is
lowest significance value is P.
Yeah, correct.
At a given C, alpha is not given at a C. We need to find C for a given alpha. It's a bit confusing, but I hope you should understand writing twice or thrice.
Alpha is the area, right? Rejection area, right?
Yes, sir. Even P is also a rejection area.
No, this P is a point, right? Which point we are? P and C are point, right?
I'm not able
P is
to.
not a point. P is also an area.
Yeah, P is also an area.
So since it's a continuous distribution, so when you talk about the probability, it always turns out to be that it's the area that you are computing. So P is essentially the area that you're computing here. And alpha is also the area as well.
Ma'am, I guess we are having time constraint. Let's agree with you only, ma'am. I feel this is right. We'll discuss.
Yeah,
let's keep this
discuss it,
research
because
work
I'm also getting
later.
confused, like what's the doubt coming, because I'm not able to understand what is the doubt. Okay, let's continue with the next question. We will take this at the last. Fine.
For this question, let's summarize this. Whatever the tail test it is, if the p-value is lesser than significance level, it will be rejected, and if it's greater than, it will be accepted. That's it.
Okay. Now, let next question. Let X be a discrete random variable with following PMF. We have the following the P is going from 0 to 1. Consider the estimation of P from the samples list. Using the above information, answer 8 and 9 questions. Find the method of movement estimate of P for the given samples. Okay, so how do you find out the method of movement?
The expectation of X equal to the sample.
First, we will find the expectation.
Yeah, first we will find out the expectation of X, which will be equal to
minus 2 into P by 2.
Minus 2 into P by 2 plus
minus 1 into, again minus 1 into P by 2 plus 0 plus 1 into P, 1 minus P by 2. So minus 3 P by 2 plus 1 minus P by 2.
What is the value that you are
expectation
getting?
Of X. Okay. 1 minus 4P by 2.
1 minus
1 by 2 minus 2P.
This is the expectation. Now the next step is we would be equating it with the equal.
Calculate the sample mean. That will be minus 1 plus 0 plus
minus 0.2, ma'am.
Minus 0.2. Now the expectation
minus 1 by
that this will be equal to minus 0.2. So that means my expectation of X will be equal to my sample mean. So if you equate this, my P will be equal to what?
When this minus 0.2, how do we get?
This is the sample mean, right? So we would be, we have the samples minus 0, then...
Ma'am, is it 0.15?
I mean, P would come out to be 0.35, right? 0.35.
0.35. Okay. So what is sample mean? So we have the samples, right? Minus 1, 0, 1, 1, minus 2, right? So we would be taking the average of these samples. So summing all the values divided by the number of samples, which is 5. So then we got minus 0.2. Fine?
Yes, ma'am.
The method of movement is, yeah, okay. So we have 0.35 as the answer. So this is the S. With the help of method of movements, we got the value of P, which is 0.35. Is this question clear?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Okay.
Clear.
Now the next is we have to find out
Yes,
the help
ma'am.
of maximum likelihood.
Yes.
Okay. So what is my likelihood here?
P by 2.
It will be the
into P by
product,
2.
right?
Yes, it will be the product.
So I is going
Product
from
from 1 to n 5. Yes.
1 to 5.
Ma'am, could you
right?
show the
We have
PDF once?
PDF. Okay. So this will be what? So first of all, I have the samples as minus 1, comma 0, comma 1, comma minus 2, right? These are my
Yes,
samples.
ma'am.
So the probability of minus 1 is?
P by 2.
P by 2.
P by 2.
P by 2 into 1 minus P by 2 for 0 into 1 means 1 minus P by 2 into 1 minus P by 2 into for minus 2 it's P by 2.
So it will be 1 minus P by 2 whole cube.
Yeah.
1 for 0, 2 for 1. 2, 1 is there. So P by 2 whole to the power 2 and 1 minus P by 2 whole to the power 3. This will be final.
Yes, ma'am. You're right.
P by 2, and
5, yes.
So this is my likelihood, right? Then next we will be taking what? The log?
Yes.
Right? So log n would be what?
Can you please explain the second line?
2 log P minus
this one?
Yeah. Yes, ma'am.
It's just like I just took the probability. For minus 1 it is P by 2. For 0 it is 1 minus P by 2. Then for 1 it is 1 minus P by 2. For 1 it is 1 minus P by 2. And for minus 2 it is P by 2. I just multiplied all my probabilities for each of these samples.
Okay. Yes, ma'am.
So this will be 2 into log p plus 2 into log 1 minus p. I'm not writing this because this will be like, you don't know, you can write it as
No, ma'am, no need to write. You just do it because.
Yeah, it's fine. So we will be taking the differentiation with respect to what?
P.
P. This will be 2 by p plus 3 by 1 minus p into minus 1.
3 by 1. Yes, yes.
Equals 0.
Yeah, so now we will be equating it equal to 0. Okay, then the value of p is coming out to be?
So 2,
what is the value that
2 minus 2p equal to 3p. Hmm. 0.4.
So this p equals to 2 by 5. So p equals to 0.4. Is the question clear?
Yes, ma'am.
Yeah. Shall we proceed now then? Okay.
Yes, ma'am.
A company has installed 2 machines A and B to fill the oil in the bottles. Standard deviation of the amount of oil from machine A and B are 0.6 and 0.5 liters. Okay. The company manager suspects that the average amount filled by the two is different. He took n samples from machine A and found the average to be this. A sample of 50 bottles from machine B results in an average amount of 1.6. If the p-value of the test is 0.01, find the value of n. Okay. So we have 2 machines, right? So
yes, ma'am. It's a 2 normal test.
A 2 sample test, yeah. So we have a machine in which the value of standard deviation is given to be 0.6. Okay. Then we have B in which the standard deviation is given to be 0.5. Okay. From this we have taken an n sample, which is we have taken n sample and the x bar is coming out to be 1.2. Correct? Then we have taken 50 and 1.6. And from here we have taken sample of 50 and the x bar is coming out to be 1.6. Yes or no? Let's take it one.
Yes, madam.
Yeah. Okay.
Yes,
now, the p value is given to be 0.5. That is, this is also in somewhat a significance value. Yes or no?
Yes, ma'am.
Yeah. We need to find out the value of n. Okay. Now we have the 2 samples here. We have the standard deviation given as well. So this is basically what? 2 samples that test.
Yes, ma'am.
Okay.
Yes.
Now what is my h naught here?
mu1 minus mu2.
No, h naught, null
Mu
hypothesis.
A equal to mu B.
Mu1 equal to mu2.
Mu A
Sorry.
equals to mu B, and my alternative would be
mu1 not equal to mu2.
To mu. Okay. Now what is my t here?
Mu A minus mu B.
X bar minus y bar.
Y bar, yeah.
And I would be rejecting h naught if
X bar
Mod of
minus
P
Y bar is greater than C.
C. Okay. Now my x bar is following a normal distribution with mu, let's suppose mu1 comma 0.6 square divided by n.
Yes, ma'am. Only
Yeah?
x bar. Okay. Yeah.
And y bar would be what? Would be following a normal distribution with mu2 comma
mu2 comma
0.5
5 square by n. 50.
So x bar minus y bar would be following normal distribution with mu1 minus mu2 comma
root of
0.6 square by n.
0.6 square by n plus 0.5 square by 50. Okay. Then p value is probability of rejecting h naught. That means my 0.01 is basically probability of if my mod of p is greater than c given h naught is true. Right? That means my mu a is equals to mu b. Yes or no?
Yes, ma'am.
Yeah. So let's normalize it. So this will be probability of mod of p greater than.
Ma'am, 1 minute.
Yes.
Can you just scroll up a bit? One line I missed actually. Okay. Thank you.
Okay. So this will be C minus. So mu A minus mu B, they are all equal. So it will be 0 only.
Yes, ma'am. C minus
Yeah. Okay. Divided by under root of 0.6 square divided by n plus 0.5 square divided by 50. Yes or
Yes,
no?
ma'am.
This
Yes,
is
ma'am.
equals to 0.01, right? So I can write this as 0.01 equals to 2 into fz of minus c divided by under root of 0.6 square divided by n plus 0.5 square divided by 50. Yes or no?
Yes, ma'am.
Okay. Now, I need the value of c here, right?
Yes, ma'am.
We need the value of n here.
Yeah, we need the value of n here. So what is the value of c according to the question?
1.6
should be equal to mod t because we p value.
So c would be the like x bar minus y bar, right? The sample.
Yes.
The
So
difference of the sample,
1.6
right?
minus 1.2.
So it will be 1.6 minus 1.2, which is basically 0.4, right? So this will be 2fz into minus of 0.4 divided by 0.6 square divided by n plus 0.5 square divided by 50. Right? This step is clear or not?
Yes. Yes, ma'am. Yes, yes, ma'am.
Okay, so this will be minus 0. So if you calculate this, what is the value that you are getting of m?
Ma'am, F inverse of
0.05
once could you say, then
Which
we
one?
could calculate.
Okay, so this will be minus 0.4 divided by the denominator part equals to 0.01 divided by 2, which is the fz inverse, right?
Yes,
So
ma'am.
which is fz inverse of 0.05, right?
0.05. 0.05.
Yes, this will be 0.05. So
minus 2.58.
minus 2.58. So this is minus 2.58. So we have the value of this, then equate this.
Yes, ma'am. We can solve it from here. Did not.
Yeah, so what is the value of n you're getting? Can you just solve it and let me know? 19.
19, ma'am.
18 point.
Everybody is getting that answer?
It's not fully 19, but I'm telling you the
approx.
Yes, it's approximate. It is more than 18 actually.
18 point something?
18.89.
Yes.
Yeah, so like just round it off and it will be approximate to 19. Okay, so you guys have solved this question? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah. Are you getting n equals to 19?
Yes, ma'am.
Yes, ma'am.
Okay. Shall we proceed to the next question then?
Sure.
Yes, ma'am.
Yeah.
Yes, ma'am.
Waiting time x of a customer at a restaurant is exponentially distributed with unknown mean 1 by lambda. Waiting time of the last 5 customers are this. Find the maximum likelihood estimate of lambda. The same process. So this will be what? My x is falling exponential with lambda as the parameter. So what is the PDF?
Lambda into e power minus lambda
PDF
x.
of lambda x, right? So maximum likelihood, that means I need to find out the likelihood function first. I is going from 1 to 5. We have 5 samples, right? 15, 10, 5, 12. So we have 5 samples, 15, 10, 5, 12, and 8. So we have 5 samples. So this will be lambda e raised to the power minus lambda x. So now this will be equal to what? Lambda raised to the power?
5.
5 e raised to the power minus lambda
Summation xi.
summation of xi, that is 15 plus 10 plus 5 plus 12 plus 8, correct?
Yes.
Yes.
And this is coming out to be what?
50.
50.
This is coming out to be 50. So we have the likelihood function. The next step is
Log 25
of
log
10.
lambda.
So 5 log of lambda minus lambda 50, right? Yes or no?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Then we will be differentiating with respect to
Lambda.
lambda. So this will be 5 lambda minus 50, right?
Minus 50.
Now this will be equal to 0. So lambda will be equal to what? So this will be 5 by 50, which is 1 by 10, 0.1. So my lambda is coming out to be 0.1. So this is by method of maximum likelihood, we got the estimate as 0.1. Yeah, correct. Is the question clear?
Yes, ma'am.
Yes, ma'am.
Okay.
Ma'am, how you write lambda to the power 5?
Lambda to the power 5. So we are just we are taking the product of all the 5 samples, right? So for each of the samples, this will be what? Lambda e raised to the power minus lambda x. Similarly for this and this. So if we are multiplying all the lambdas 5 times,
Yes.
it will be raised to the power 5 only, right?
Yes.
Yeah, that's why we
Then
got lambda raised
after lambda to the power 5, can't we write lambda to the power 5 e to the power minus 5 into all the xi, into the summation of all the xi's? Like in place of minus lambda, can't we write minus 5?
Why?
Because lambda to the power 5.
No. So, like we are taking the product, right? So it will be lambda e raised to the power minus lambda x1 into lambda e raised to the power minus lambda x2. Similarly, it will go on till lambda e raised to the power minus lambda x5,
Oh,
right?
that's like now I get.
Okay. Now, next question is find the posterior mean of lambda using exponential 1 by 10 as the prior. So we have the prior distribution. Okay, so prior is what? Exponential with 1 by 10 as the parameter. So this is my what? Lambda, right? Okay.
Yes, ma'am.
So if we need to find out the posterior mean, we need to find out the posterior distribution, which is proportional to what?
Likelihood times prior.
Yeah, so this is likelihood into prior. So what is my likelihood here? It would be lambda raised to the power 5 into e raised to the power minus 50 lambda, yes?
Yes, ma'am.
And what is my prior? Prior would
1
be
by 10 times e to the power minus
lambda
1
by
by
10.
10
So
into
this is a constant term, so we won't be taking it. So we would be having lambda raised to the power 5 e raised to the power minus 50 lambda.
Like 1 by 10 is lambda. Then why didn't we put like in the e raised to power like lambda in place of that? We should have put 1 by 10.
1 by 10, right?
What?
It's because it is the prior for lambda itself.
This prior is basically, what is my prior? This is the lambda. So, okay, so when we are doing Bayesian estimation, what is the case? I am having a sample which is following an exponential with parameter lambda. Now, this lambda is following some distribution which is exponential 1 by 10. Got the point?
Okay.
Ma'am, she's saying in place of 1 by 10 times e power minus lambda by 10, that lambda should be minus 1 by 10, right? Sorry.
She got the point. So she is basically what she is saying. We have lambda e raised to the power minus 50. Like we have e raised to the power minus lambda x, right? So in place of lambda, she is saying that it should be 1 by 10, right?
Yes, ma'am.
Yeah, but it's not the case, right? So, okay, so if I'm saying my x is following exponential with parameter as lambda, then I say e raised to the power minus lambda x. My x will be the values, right?
Okay, yeah. Here,
Yeah.
lambda
So
itself
now
is following that, right? Okay.
Okay.
Got it. Sorry.
Okay, so this is lambda raised to the power 5, e raised to the power minus 50 lambda, e raised to the power minus lambda by 10. So this will be proportional to lambda raised to the power 5, e raised to the power minus lambda common. So I would be having 5, right? Okay, this will be plus, sorry.
No, ma'am, it will be 50 plus 1 by 10.
50 plus 1 by 10, which is 50 plus 0.1. So this will be lambda raised to the power 5, e raised to the power minus lambda 50.1. Now this is following which distribution?
Gamma.
This is following gamma distribution with parameter
5 and 50.1.
6, right?
6.
6 and 50.1.
Yeah, 6. Yeah.
50.1.
Yeah, 6.
Right? For gamma, it is basically what? X raised to the power alpha minus 1, e raised to the power minus beta x.
Beta x.
Yes.
So this is my posterior distribution. Then what is my posterior mean here?
Alpha by beta.
Alpha by beta, which is 6 by 50.1.
50.1.
So this value is coming out
0.119.
0.119.
Ma'am, that is alpha to the power 5, but we made it 6 because it is minus 1.
Sorry, once again, what?
Alpha to the power 5, then e to the power minus lambda to, within bracket 50.1. So b minus beta x means, so that is the value of beta, but alpha value is that is 5, right? Okay, it is 6.
No. So it will be 6, right? So my if you compare it with this equation, so alpha minus 1 is coming out to be 5. So
yes.
alpha would be what? 6, right?
Plus, yeah.
So this is coming out to be 0.119, or you can say 0.12. Fine. This is the answer. Is the question clear?
Yes, ma'am.
Everyone?
Yes, ma'am.
Yes, madam.
Okay, now 13th question. Let x be a continuous random variable. We have fx. Determine the CDF of x. How do you calculate the CDF?
Integrate.
You integrate with the values. We have fx as 0 to 6, x 1 minus x, where x is going from 0 to 1. So if I need to find out fx, it would be, I would be integrating from 0 to
x. 1.
X.
Sorry.
Yeah. I would be integrating.
That would be, if we make it to 0 to 1, that would be 1, right, ma'am? Total answer would be 1.
Total.
Okay. Yeah. Sorry.
So this will be 0 to x, 6x, 1 minus x dx. Okay. So I can 6 is a constant term. So this will be 0 to x minus x squared dx. Okay. Now this will be 6, 0 to, okay. So I can write this as x squared by 2 minus x cubed by 3, right? 0 to x. Can I write it?
Yes, ma'am.
Yeah. So this will be 6. Yeah, basically it will be x squared by 2 minus x cubed by 3. So now this will be equal to what? 3x squared minus 2x cubed divided by 6, right? So it will be equal to 3x squared minus 2x cubed. Yeah.
Yes, ma'am.
So I can write this as, yeah. So I can take common x squared 3 minus 2x.
Ma'am, please scroll down.
Scroll up or down?
Down.
Down.
Up.
No. Any doubt?
Ma'am, in differentiation part, I just doubt.
What? Integration.
Yeah, after integration, like x minus x square.
So I just integrated separately. Okay. So I first integrated x, then I have integrated x square.
Like you okay, x square by 2 minus x cube by 3. Yes, okay.
Okay, so I'm integrating x first, then again I'm integrating x square.
Yeah, it's
okay?
fine. Yes.
So this is 3x square minus 2x cube, which is x square multiplied by 3 minus 2x. So option, which option is it? D. Is the question clear?
Yes, ma'am.
Okay, everyone?
Yes, madam.
Yes, ma'am.
Okay, now the density function of a continuous random variable is given. Let 10 samples be this taken from x. Find the maximum likelihood estimate of sigma. The same thing, same process. Okay, so what is fx given? Fx is given to be 1 by 2 sigma exponential of minus mod of x divided by sigma. So we need to find out the maximum likelihood estimate. So first of all, you will be finding out the likelihood estimate. I is going from 1 to
10.
I is going from 1 to 10. 1 upon 2 sigma e raised to the power minus mod of x by sigma. So in general, it would be what? 1 by 2 sigma raised to the power 10. Yes or no?
Yes.
Yes.
And e raised to the power minus mod of x, like mod of x1 divided by sigma minus x2 divided by sigma till minus of x10 divided by sigma, right? So I
Yes,
can
ma'am.
write this as 1 by 2 sigma raised to the power 10 e raised to the power minus 1 by sigma common, and it would be sum of the mod of x1 till mod of x10, right?
Yes, ma'am.
Yes, ma'am.
So the addition of, so the thing is I would be taking the mod. So if you take, in the samples we have the negative values, right? -2, -4, -1, won't be taking the negative sign. So we would be taking only the mod of values, which is 4 plus 2 plus 2 plus 1, like that. Okay. So if you take the sum of sample, what is the value that you are getting?
30.
4 plus 2 plus 2. Huh?
30.
You are getting 30. This thing is clear? How we got 30?
Yes.
Yes,
Yeah.
ma'am.
Okay.
We
So
added
we
all
have
the positive values.
we have added all the positive values because it is asking the mod of all the values. Okay, the absolute value. Okay. Now.
Slight small doubt. It has minus mod x, right? Minus is outside the mod. Then
No, minus sign is not inside the mod, right? It is outside mod of x. See, minus of mod of x1, minus of mod of x2.
out itself, right? Minus 1 by
Sorry.
sigma.
Once again, what? Okay. So log of L would be what? So this will be minus 10, right?
Yes, ma'am. Could you do that step? I guess people will have confusion.
Yes. Yes, ma'am.
Okay, so if I take 1 by 2 raised to the power 10, 1 by sigma raised to the power 10, e raised to the power minus 30 by sigma, so I can write this as 10 log of 1 by 2 plus 10 log of 1 by sigma minus 30 by sigma. This is my log of L. Okay. Now, I will differentiate it with respect to sigma. So this will be 0 only. Now this will be 10 into sigma.
Ma'am.
Into minus 1 by sigma
Minus,
square.
yes,
correct?
yes, ma'am. Yeah.
Okay, and this will be what? Plus 30 by sigma square. 1 by
Yes,
sigma.
ma'am.
I would be
Minus 1 by
1
sigma square. Plus, yeah.
So this will be
Can you
minus
come
10.
again with these steps again?
Okay, so the first thing is I would be differentiating 10 log by 1 by sigma, right? So first of all, what this would be 10, the log value I would be differentiating, it will be 1 by sigma. Then I would be differentiating the inside part, which is 1 by sigma. So if I differentiate 1 by sigma, what is the value? I can write 1 by sigma minus 1, yes or no?
Yes, ma'am.
Yeah. So sigma minus 1 can be differentiated as minus 1 into sigma minus 2, right?
Yes, ma'am.
So I can write this as sigma will come to the numerator. This will be 10 into sigma divided by sigma square.
Yes, ma'am.
So this will be 10 by sigma. Yes or no?
Yes.
Okay. Similarly, now this is minus 30 by sigma. Same process. That is, I have to differentiate minus 1 by sigma. So this will be what? I can write this as minus sigma raised to the power minus 1. Now I have to differentiate this value. This will be minus 1 sigma raised to the power minus 2. So minus plus, this will be 1 by sigma square. Is this fine?
Yes, ma'am.
Okay. So I got the value of minus 10 sigma plus 30 by sigma square. Now this will be equal to what? 0?
Yes, ma'am.
Okay. Now if you solve this value, you will be getting 30 by sigma square equals to 10 by sigma. So sigma will get cancelled. So my sigma will be equal to 30 by 10, which is equals to 3. So my sigma is coming out to be 3. Is this question clear?
Clear, ma'am.
Clear,
Can you
everyone?
scroll up a bit? Just scroll up a bit.
Yes, madam.
How did we got plus 30 by sigma square? I'm getting minus 30 by sigma square.
We have minus sign here as well, now.
Where? Okay. Chain rule. Okay, sorry.
Yeah.
It's a mistake.
Okay, can I proceed further now? Any more doubts?
No, ma'am.
No? Okay. Now, suppose the number of diseased people in a week because of a deadly disease in the country has a Poisson distribution with lambda as a parameter. A researcher wants to estimate lambda. From studies in other countries, prior mean is given to be 3 and standard deviation is given to be 1. He decides to use gamma as the prior that matches his prior mean and standard deviation. The number of diseased people recorded over the next 10 weeks are this. Find the value of alpha and beta. Okay, so prior mean is 3 and standard deviation is 1. Okay. Now, for gamma distribution, my with parameters alpha comma beta, what is my mean?
Alpha by beta.
Alpha by beta.
Alpha by beta. And this value is coming out to be 3, right? And what is the standard deviation?
Alpha by beta square.
Root by beta square.
Alpha by beta square. So let's suppose the variance, okay? So this variance standard deviation is coming out to be 1. So my variance will be equal to 1 also?
1 also, yes ma'am.
Yeah. So my alpha beta is 3 and alpha beta square is equals to 1. So I can write this as alpha by beta into 1 minus beta equals to 1. Right? So now alpha beta is 3. So this will be 3 by beta equals to 1. So with this thing, my beta is coming out to be 3.
Yes, ma'am.
So now this alpha would be equal to 3 into 3, which is 3 into, this is my beta. Right? So this will be 9. So my alpha is 9 and beta is 1. 3. Is it clear?
Yes, ma'am.
Everyone?
Yes,
okay.
madam.
Now
Yes,
find the
madam.
posterior mean of lambda. So what is the posterior mean of lambda? So first of all, I need to find out the posterior distribution, which is the likelihood into prior. Yes. What is my likelihood here? Lambda is following, the samples are following what? Poisson distribution?
Yes, ma'am.
So this will be the product of I going from 1 to?
1 to number of products. Sorry, number of
samples, right? So 1 by 1 to 10, e raised to the power minus lambda,
Minus
lambda raised to
lambda.
the power xi divided by factorial xi, right?
Yes, ma'am.
Into
gamma.
prior, what is my
Gamma.
prior? Lambda raised to the power 8,
8.
right?
Okay. Yeah. E
And
power minus lambda into 3.
Lambda into 3. Okay. So now if you solve this, you will be getting e raised to the power minus 10 lambda, lambda raised to the power sum of all these samples.
Ma'am, before proceeding, could you please explain that the first line, how did we arrive these numbers? Lambda
Which one?
to the
This
power
one?
Yes, yes.
Okay. So my prior distribution is lambda is following what? Gamma with 9,3 as the parameter. Yes or no?
Oh, yes, ma'am.
Yeah. So for gamma, it is x raised to the power alpha minus 1, e raised to the power minus beta x. Yes.
Yes, ma'am.
So in place of x, I have lambda here.
Yeah.
So lambda raised to the power alpha is 9. 9 minus 1, 8.
Yes, ma'am.
And e raised to the power minus beta. Beta is 3 into lambda. Fine?
Okay, okay.
Okay.
Ma'am, is this actually the PDF? Like, what is this? X to the power e alpha minus 1?
This is the distribution. The PDF.
PDF. Ma'am, is there any other place where I can actually get the formulas for all of this?
The formulas in the sense
Sheet
like
of
the, yeah, it's like in the question paper, the sheets will be given, right? The formula sheets.
Like, you don't need to memorize these, okay?
Sorry, your voice.
Like, I'm asking, like, we don't need to memorize all of these, right?
No, you don't have to memorize. Already you have the formula sheets and all. So you can memorize well and good, but otherwise you can see in the formula sheet.
Okay, ma'am. Okay, ma'am.
Okay. Now, do this with summation of xi. What is summation of xi?
46.
It is 46. So I can write it as lambda 46 plus 8 e raised to the power minus lambda 10 plus 3. Yes or no?
Yes, ma'am.
Sure?
Yes, ma'am.
Okay. So this will be lambda raised to the power 54.
Yes, ma'am. Yeah.
E raised to the power minus 13 lambda. Now this will be following what distribution?
Gamma 55 and 13.
Gamma
13.
55 and 13. Now what is the posterior mean? It would be 55 by 13, which is equals to
4.23.
4.23. Yeah. Fine. Till
Yes,
here,
ma'am.
all the questions are clear. Till 15.
Yes, ma'am.
Sure. Okay. Then the last question. This is an important question. Okay. So we have used the following values if required. A battery manufacturer claims that the newly designed battery lasts on an average of 11.5 hours on a full charge. A researcher believes that the average battery life is actually higher than what the company claims. To test the claim, the researcher selects a random sample of 25 batteries and tests them under standard conditions. The mean and standard deviation of the observed samples are these. Assume that the battery life follows a normal distribution. Consider a test that rejects the manufacturer claim for some constant C at 5% level of significance. Find the value of C. So we have the question here. We have the solution. Let X represent the life of a newly designed battery. The null and alternative can be defined as X naught will be mu equals to 11.5. What will be my alternative?
Mu is
mu greater than 11.5.
11.5.
Mu will be greater than 11.5 because the researcher believes that the average battery life is actually higher than what the company claims. Company is claiming 11.5. So alternative would be mu greater than 11.5. So that means option number 2. Yes? Okay. Now under H naught, the test statistics will be, this will be following what distribution?
Normal.
Normal with?
8 number.
8 number.
Mu and sigma squared by n.
Yes, ma'am. 8. It would follow 8 only, right?
Why?
Tn minus 1.
Why?
Tn minus 1, right?
Why?
Distribution, right? Tn minus 1
Yeah.
distribution.
Why not normal?
Because
We have the sample is given, right? Not the population.
sample is given, right, ma'am?
Sample.
It's not population sigma, right? It's
Ma'am, like
sample.
variance are unknown here.
Correct. The variance is unknown here because we only have the population mean. We don't have the population variance. So that's why we are taking the t distribution. So x bar minus mu naught divided by s upon under root n will be following t distribution with degree of freedom n minus 1. Okay. Now to find the value of c, we will have alpha equals to probability of rejecting h naught this. Then alpha is 0.05 now. What will be my 3?
X bar minus 11.5 by
Yeah, x
Yes,
bar
X
6.
bar
X
greater
bar
than
greater
C.
than C.
C.
Okay. Now, next step is 0.05. I'm converting this into a standard T distribution. So at 4, it will be
C
FZ
minus.
13, I guess.
I think firstly we should write C minus
10 number,
11.5 by sample. Yes, 10 number.
Yeah, so it will be C minus
It will be
11.5.
11 number. It should be 11, right? Because
Not
we have
11.
f of
Divided by
No,
2.5 by
we are
5.
yes, ma'am. It should be 10 or 12 based on the given values.
Based on the sample standard deviation.
So 0.05 will be probability of x bar minus mu naught divided by S by under root n, right?
Yes, ma'am.
This will be greater than C minus. What is my mu naught?
11.5.
Divided by what is the sample standard deviation?
Could you show the question?
Uh,
Yeah, 2.5.
2.5, right? So this will be 2.5 divided by
under root 10.
Root 25.
25 samples. So this will be
It means
5.
5.
So this will be my value, right? So if you
Yes,
see
ma'am.
here, this is 10. Fine?
Yes, ma'am.
Till here it's fine. Then the next thing is this can be written as 1 minus fz of C minus 11.5 divided by 0.5.
But we
Yes,
should
ma'am.
use T na, instead of FZ.
Sorry.
Yeah,
N minus
Tn
1.
minus 1.
Huh.
T24
So-
also you should write, ma'am. It's better.
Okay, so this can be written as ft24 C minus 11.5 divided by 0.5 equals to 0.95.
Yes, ma'am.
Okay, the next step is written as. So at 5, what will be my value? This value?
Yes, ma'am.
So this is ft24 C minus 11.5. This
11.
one?
Yes, ma'am.
11. Okay, then we have to calculate the value of C. So C minus 11.5 divided by 0.5 will be equal to FT inverse.
FT inverse.
Yeah,
24.
What is that value?
0.95.
Which value will we take?
1.711, right?
1.711. FT24.
So it will be 1.711. Now C would be what? 1.711 into 0.5 plus 11.5. So 11.5 plus what will be my sixth value? It will be
0.85.
0.85.
yeah 0.85. So this is 0.85 plus 11.5.
Yes, ma'am.
12.35.
Then the C value is coming out to be
12.35.
12.35. That's it. So we have 12.35 here. Oh, like now. Is this question clear?
Yes, ma'am.
This one?
Yes, madam.
Yeah,
Ma'am, I guess half of the paper will carry that one question, right?
Yeah, one question is there.
Ma'am, I have a doubt in such questions. Like I have seen somewhere, like it is explicitly mentioned to enter the answer into 2 correct decimal places. At the same time, that option is also given one among those options, set of options mentioned. In that case, I should put the option number or value to 2 decimal places.
Where, once again, what?
For the last question, it is mentioned that enter the answer correct to 2 decimal places, right? If that option is given as a set of options for this particular question, should I put that option number or I should write the answer to 2 decimal places?
If they're saying that we have to enter the answer, then you have to enter the answer. Otherwise, you have to just write the option number.
Okay,
But
even though if
mostly,
it is
mostly this type, like calculate the value of C, it would be like you have to write the answer, not from the option. It won't be there.
Okay, right.
Okay. Anything else? So is the
Yes,
question
ma'am.
paper clear?
Ma'am, this is yes, ma'am.
Yeah. Yeah, you were saying something.
Ma'am, so like most of the weightage would be from 9 to 12 only, right?
60 to 70%. Yeah, 60%.
Like the weeks 1 to 8 also more sort of basic questions
Basic question.
are there.
Simple.
Like I thought more sort of integrations of random
Nah.
variables would be given.
No. It would be just a simple question.
Okay, and
Not that
time
bad.
constraint might be the case. That's why they're not giving is
Correct,
it so?
correct. Yes. So
Okay.
mainly the question,
Okay.
most important question would be from 9 to 12, like concept wise and everything. And the basic questions would be from 1 to 8.
Ma'am, like in mocks, there was no question on bias, risk.
There won't be.
And even bounds also, Chebyshev's bound, Markovnikov inequalities are.
Ma'am, will you please explain CLT in short, just central limit theorem?
Central limit
Actually, yes. I am always confused in MLF and CLT.
CLT. I don't think so. It's there in the
Ma'am, CLT is same as like normalization only, right?
It's same. Like they are saying that all my samples, if I increase my samples, it would be following, like it would be approximately equal to the normal distribution. That's my point of CLT. With
Like
mu and
if we have mu and sigma, I have to change it on a standard normal distribution.
So if you have to change it into a normal distribution, I would be standardizing it with so that my expectation is coming out to be 0 and variance is coming out to be 1.
Like in Chebyshev's, we see for greater than or less than for 1 by k square, 1 minus 1 by k square, and for Markov's it's mu by c. For CLT,
for CLT, it's like nothing. You just have to convert into a normal distribution. That's it. Approximate it to a normal distribution.
Okay.
Yeah.
Ma'am, it is the same like as we are doing in the questions, minus mu divided by sigma.
Yeah. So we are just like we are saying that my T is like my X bar is following a normal distribution with mu comma sigma square by n, right?
Yes, ma'am.
And then we are standardizing it. Yeah, that's the same thing. We are just converting something into a standard normal variant.
Yes, ma'am.
So that it follows a normal distribution with 0, 1 as the like the variant mean and the variance. So that is my central limit theorem. Okay.
Yes, ma'am.
Yeah.
But
ma'am, so the paper would be the more sort of this level only, right?
One more inequality. We have one more inequality, right? Variance by n time delta square.
Sorry, one second. What?
We have one more inequality, right? Variance by n into delta square.
That is, I guess, Chebyshev inequality, no?
Yeah, weak law. I guess weak law of law.
I just see and told you.
Ma'am, all these inequalities are same, but they are coming with different names, right?
Yeah, we have Markov's inequality, then we have Chebyshev, then we have weak law of large numbers.
Ma'am, weak law of large numbers is also Chebyshev's inequality with sample means divided by n. Ma'am, it's so confusing. Like it's like intimidating with many names. The same equation.
The main thing is you just write it down in like just write it down in one page and just learn it. That's the simple thing that you can do.
Yes, I was talking about weak law of large numbers. That's a formula of that, like
I have a few questions
sigma
from
square by n
PYQ.
into delta square.
Yeah, so the weak law of large number is basically it's coming out from the Chebyshev inequality, no?
Yes, same as.
Same. So in weak law of large number, we are taking x bar. Right? X bar.
Ma'am, I have few questions from PYQ.
What is your question?
And I've shared a link of PYQ space.
Which question?
Question number 7, ma'am.
Given that the household has already consumed more than 2 kilowatts of electricity, what is the probability that its total consumption for a day will be below 4? So that's a conditional, right? Probability of x less than 4 given that x is greater than. This is household. That probability of x is less than. This will be the conditional distribution. So we need to find out probability that x is less than 4 given that my x is greater than 2. Right? Yes or no? That it has already happened. So more than 2 kilowatt has already been consumed. Okay, this is the given, and we need to find out the probability that the total consumption is below 4 kilowatt. Right? So it will be probability of x greater than 4 given that x is less than. Sorry, x is less than 4 given that x is greater than 2. Right? Fine.
I have to mean, so what I have to do in that?
We need to find out the conditional thing, right? You know how to find out the conditional.
Ma'am, is the class over? Can we leave if possible?
Yeah, you can leave. If you don't have any doubts, you can. Yeah.
Ma'am,
Thank
I
you so
have
much,
a
ma'am.
doubt from PYQs.
Yeah, we are solving the PYQs only.
Yes. After that, I will tell you the doubt.
Oh. See, I'm not going to solve the whole question, okay, Om? So I'll just give you the basic thing.
Okay.
Yeah, just the basic thing. You need to find out probability that my x is less than 4 given that my x is greater than 2. You need to find out this thing, more than 2, right? So I can write this as, so what is this? Probability, if x is less than 4 and x is greater than 2, that means it is going from 2 to 4 divided by probability of x greater than 2. Yes?
Yes, ma'am.
Now you can find out, you need to find out this value and you need to find out this value.
Okay.
So this will be what? I can write this as 1 minus probability of x less than 2. And in the question also, PDF is given, right? Huh. So you need to find out both of these values. Fine?
Yes, ma'am.
Yeah. Any other question?
22 number, ma'am. 22 number.
Suppose the researcher decides to increase. Okay. Based on the above data, answer the given subquestion. A medical study is testing the claim that the average sleep. This is the question, right?
Yes, ma'am.
Medical studies testing the claim that the average nutrition that increase depending on standardization with the temperature average is greater than this. Random sample of 3 times of 54 individuals and critical region at this. Okay. Now, suppose the researchers decides to increase the sample size of 64 by keeping the same rejection threshold. What will be the effect of level of significance? So we have increased the sample size from 64 to 100. Okay. Increase the thing equal to 100. Have you calculated the value?
I was getting problem, ma'am, calculating it.
Did you how you are calculating?
I was continuing with normal from like 7.75 minus 7.5 by sigma square by n. This one.
So this is right. I don't think so. It should change. The significance level will be same only. If we increase the
Answer is
sample,
different.
different medical.
It is decreasing, ma'am.
Suppose the research decides to increase the sample size of 50 to 100 while keeping the same rejection threshold. Okay. Same rejection threshold is same. What will be the effect on level of significance?
It should increase, no? Because our sigma by root n would, because here we are changing the n, so n increases, so sigma by root n decreases. So this entire thing increases, no?
X square is significant. Is equal to mu naught will be
7.5.
5. So this is the probability of X star greater than 7.5 minus 7.5 divided by the standard population is 1.2 divided by 110. It is 64, right? So wait. If you solve this, what is the value that you are getting? The value of alpha? Can you tell me?
1 second. The value is 1.33.
1.83. This is my alpha value.
No, ma'am, it is not alpha value. It is the value
So
of
I need
fz.
yeah. What is the alpha value that you are getting?
Zero 0.91.
0.91.
Yes, ma'am.
So
it is a alpha value. Oh, 1 minus 91. It's 0.09.
It is 0.09. And what is this value? This value is coming on to be
1 second. Zero 0.05.
0.05. Sure.
Yes, ma'am.
Yeah. So this is for the case when the 64 was the sample and I have increased, so my level of significance will decrease. 0.09 to 0.05. Yeah, so my level of significance will be decreasing from 0.09 to 0.05. Okay, threshold is good. Yeah, so the option will be D. Yeah.
Okay.
What was the doubt?
Oh, this one, ma'am. I was getting confused here. Oh, what should I do here now?
Okay. Yeah, so we are just like we are having 0.09 for the case of 64, right? Then when we had 100 as a sample, we had 0.05 as the level of significance. So the level of significance has reduced. So if we increase the sample with the same threshold, we will be having low significance level. The decrease, it will decrease actually. Okay.
And yes, ma'am.
Anything else?
Will we get questions from the chi-square test and bias and this risk as well?
No.
Okay. So there won't be questions from this.
No.
Ma'am, I've said one more link, ma'am. And
Which question?
it is question number 17.
Based on the above data, the joint is given to be this, where P is constant. Find the marginal distribution of X. How you want to calculate? First, you have to calculate the value of C. So if you just integrate the whole value, double integration from 0 to infinite for the y and 0 to x, 0 to infinite for the x, P e raised to the power minus x plus 2y, right? Yeah. So you have to first differentiate it and find the value of C. Then after that, if you have the value of C here, then you will calculate the marginal distribution of X. How you want to calculate the marginal distribution of X? By integrating with respect to Y. Okay?
Okay, ma'am.
Yeah.
It's okay.
That's it?
Yes, ma'am.
Okay.
Could you upload the PDF in C?
Yeah, I'll just. By
share it
tomorrow
now.
it will be uploaded.
Okay.
Okay?
Hello, ma'am.
Yes.
Ma'am, can you please explain question 5 again? I didn't get it. Why HA? Question 5 in the mock. From the mock that we have discussed. Yeah.
This one?
Yes, ma'am. I didn't get why HA is, P less than 0.15. It should be greater than, right?
No. In the question it is given that. See, the question is the standard method of screening fails to detect the presence of the disease. So in 15% of the patients. So it is saying that it is failing to detect the presence, which is 15% of the patient. Because what is my P here actually? P is detecting the presence of the disease, right?
Yes,
or
ma'am.
no?
Yeah.
That's okay. Now the thing is to determine if the new method of screening is superior. So my alternative would be what? My P should be less than like detecting, it should be less than 15%, right?
Oh, yeah, ma'am. Yeah.
Yeah.
Okay. Yes. Ma'am, also one question that, like, for hypothesis test that we are studying, we need to, go for variance test also. Yeah. Is it enough to prepare for test for mean for hypothesis test?
Yeah, we have to study for mean. Yeah.
Not for variance.
No.
Okay.
Chi-square and F-test is not coming. Yeah.
So we have to prepare for Z test and T test, right? Okay. Okay, ma'am. Thank you.
Ma'am, the kind of questions we discussed today, so are we going to give the similar?
Yeah, similar type.
Similar type and from the similar sections, right? For example, maximum likelihood or posterior.
Method of movement.
Thank you very much, ma'am. You explained it very nicely.
So, thank you, everyone. So, all the best. Okay.
Thank you, ma'am.
Yeah. Prepare well. Yeah. Okay. Bye, everyone. Have a great night.
Thank you.
Thank you, everyone.